Good morning, everyone. Myself, Ritika Chettipalli from CSC branch, section D. Today, I am going to present a PPT on topic called chemical precipitation in drinking water of course engineering chemistry. First, what is chemical precipitation? Why it is used? Chemical precipitation is used to remove contaminants from the drinking water by adding chemicals that cause dissolved substances to form solid particles which can then separate it. This process is used to remove dissolved salts or ions like hardness, chemical and magnesium, heavy metals, and ions such as phosphates and fluorides. Key factors controlling the process are called pH and temperature. And a major byproduct is the creating of sludge. How chemical precipitation works. Addition of chemicals. Soluble chemical reagents are added to the water to react with dissolved components. Formation of precipitants. The reaction creates an insoluble solid or precipitate from the dissolved contaminants. For example, adding a chemical that causes lead ions Pb plus 2 to form lead carbonate PbCO3. Separation of solids. The solid precipitates are removed from the water typically through settling and filtration. Common applications in drinking water treatment. Water softening. Removing calcium Ca plus 2 and magnesium Mg plus 2 ions that causes hardness. Heavy metal removal. Eliminating toxic heavy metals like lead Pb plus 2 and arsenic As plus 2 that may be present from industrial pollution or corroding pipes. Phosphate and fluoride removal. Removal ions like phosphate PO3 and fluoride F minus that can present in water. Key factors and challenges. pH and temperature. These are crucial parameters that must be carefully controlled to maximize the efficiency of the precipitation reaction. Chemical dosage. The correct amount of reagent must be added. Too little will result in incomplete removal, too much result in other problems. Sludge production. The process of generating a significant volume of solid waste sludge that must be managed and disposed of, which can be major drawback. Chemical precipitation in drinking water. Chemical precipitation is a crucial process in water treatment that remove contaminants ensuring in safe drinking water. This method utilizes chemical reaction to form solid particles which can be then removed or filtered. Understanding the principle and applications of the chemical precipitation is essential for improving water quality and public health. This presentation will explore in mechanism, benefits, and real-world applications, highlighting its significance in modern water treatment facility. Introducing to chemical precipitation. Introduction to chemical precipitation. Methods for contaminant removal. Chemical precipitation effectively removes contaminants from the drinking water, enhancing safety and compliance with health standards, such as EPA's maximum contaminant levels. Targeted contaminants. This method is particularly effective for heavy metals like cadmium, as well as lead, as well as phosphates, which contribute to water pollution and heteropollution. Formation of insoluble compounds. Chemical reaction in precipitation creates insoluble compounds that can be easily filtered out. Ensuring cleaner water and reducing harmful substances is the supply. Ensuring safe water quality. By utilizing chemical precipitation, water treatment facilities can significantly improve drinking water quality, safeguarding public health and meeting regularity requirements. Identify contaminants. Conduct a thoroughly analysis of the water sample to determine the specific contaminants present in that water required removal. Select reagents. Choose appropriate chemical reagents that will effectively precipitate the identified contaminants from the water. Mix reagents with water. Carefully add the selected reagents to the water supply and mix thoroughly to initiate the precipitation reaction. Remove precipitate. Use filtration or allow the mixture to settle to separate, then remove the solid particles from the treated water. Comparison. Precipitation agents in drinking water. There are two precipitation agents, chemical hydroxide, calcium hydroxide and sodium carbonate. Calcium hydroxide, effective for removing hardness and heavy metals like lead and cadmium, whereas sodium carbonate best suited for softening water and reducing alkalinity. Calcium hydroxide pH higher pH adjustment capability which aids in coagulation, whereas in sodium carbonate less effective for heavy metal removal compared to calcium hydroxide. Generally lower cost and widely available in many regions, whereas sodium carbonate can be more expensive and less available in certain areas. So, calcium hydroxide precipitation agent is more used in drinking water treatment. We can see a flowchart of factor influencing precipitation efficiency. First start point. Identify the water quality. Then test the pH. Then proceed with precipitation. Do not adjust the pH levels. Then end point. It is treated. You can observe a graph representing the pH levels of precipitation efficiency. Blue color indicates pH at 5, green indicates pH at 6, orange indicates pH at 7, and red indicates pH at 8. Impact of effective precipitation in drinking water. 80% of those are used to lead removal in treated water, whereas 90% is removed as precipitate reduction achieved through chemical precipitation. It signifies the public health improvement documented outcomes in community. Case studies in chemical precipitation. There are we consider two sheets which is X and Y. In X, we are going to remove lead metal, and in Y, we are reducing the phosphate reduction. And we will see what is the success in doing this. First, we consider lead removal in CTX. CTX implemented a chemical precipitation process, reducing lead level by 95% in drinking water, ensuring compliance with EPA standards and enhancing public health. Whereas phosphate reduction in Lake Y. Lake Y treatment facility utilizes chemical precipitation to decrease phosphate concentration by 80%, significantly improving water quality and restoring aquatic ecosystem. Success story in treating both the X and Y lakes. Numerous treatment plants across the US report successfully chemical precipitation outcomes, achieving over 90% contaminant removal and enhancing overall water safety for communities. Frequently asked questions on this topic called chemical precipitation in drinking water. First, water contaminants and which contaminants can be removed effectively through chemical precipitation. Chemical precipitation is effective in removing heavy metals like lead, copper, and cadmium, as well as certain phosphates and sulfates from drinking water. How do we determine the right reagent for precipitation? The selection of reagent is based on the specific contaminants present in water, their concentration, and the desired removal efficiency, often determined through water quality testing. Water environment impacts of chemical precipitation. Like how is environment affected by chemical precipitation process? While chemical precipitation can be reduce contaminants in drinking water, improper disposal of sludge and reagents can lead to environmental harm, necessitating careful management and compliance with regulation. How we can maintain compliance with water quality regulation? Regular monitoring of water quality, adherence to treatment protocols, and documentation of process are essential to ensure compliance with local and federal water quality standards. Conclusion. By this, what we can conclude is chemical precipitation is a vital process for ensuring safe drinking water by removal contaminants effectively. Takeaways. Takeaway include the importance of selecting appropriate chemicals, monitoring pH levels, then optimizing dosage for efficiency, Then moving forward, further research into innovative materials and methods can enhance this process. By adopting these strategies, we can improve water quality and public health outcomes, paving the way for sustainable water management practices. By doing this chemical precipitation in drinking water, we are ensuring the safety of the environment, safety of public health, and removing many contaminants from the water, and decreasing the pollution of water pollution, air pollution, etc. Thus, chemical precipitation in drinking water is very useful and allows us to drink safe water and pure water. Thank you, everyone.